In the concept video, we said sigmoid slope tops out at 0.25, while ReLU keeps a slope of 1. Let's not just take that on faith. Let's measure it in code. First, the good news. Every activation we discussed is a single line in PyTorch. Sigmoid, ReLU, Leaky ReLU, GELU. You give it a row of numbers and it gives them back transformed. Now the part that actually matters. Let's write a tiny helper that measures the biggest gradient an activation lets through. It uses the same autograd from the backprop video. Turn on tracking, call backward, and read the gradient. And here is the moment of truth. We run our helper on sigmoid and on ReLU. There it is. In real numbers, sigmoid lets through at most 0.25. ReLU lets through a full 1 4 times more. Stack a few layers, and that difference is the gap between a network that learns and one that stalls. One last practical thing. In a real model, the activation lives on a single line. Swapping ReLU for GELU, or any other, is a one-word change. So it is easy to try a few and keep what trains best. So the slope is not just theory. It is a number you can measure, and it explains why ReLU and its cousins rule the hidden layers. Next, we head back into the fight against overfitting with dropout, batch normalization, and the rest of the regularization toolkit.